All right, so it came to my attention that I didn't cover this, or it didn't get communicated real well, how to do some subtraction with these Maclaurin series. So let's do this one again. So I have x minus sine of x divided by x squared. And I changed the notes a little bit, so you don't have to redo them. I just want to give you extra problems. So here's sine of x, and I want you to know that when you put up the write out the first few terms, that's going to help you to know how to take away something. So when I plug in, excuse me, n equals 0. So when I plug in n equals 0, I get a positive 1. Here I get an x, and then over a 1 factorial. So the first term is x. The next term, when I plug in n equal 1, right, that's the n equals 0 term. When I plug in n equal 1, I get a negative x cubed over a 3 factorial, right? And then it continues on with the odd terms. So for this to say x minus sine of x, so x minus, and I'm just going to write x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, dot, 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 dot. These two x terms go away. Then I also have this negative out in the front here, right? So this negative will change this to a positive. So x minus sine of x, just looking at the top, the numerator, right? X minus the x goes away. Subtract off this, it turns into a positive x cubed over 3 factorial, negative x to the 5th over 5 factorial, right? And so if I was to write this as a sum, I would want to just change it to starting at 1. Because when I plug in 1, and I have my 2n plus 1 factorial in the denominator, and my x to the 2n plus 1, and I'm going to see what happens with this power of negative 1. So I want the first term to be positive now, right? So I want this to be n plus 1. Remember, I always encourage you to use negative 1 to the n or n plus 1. Okay, so this is the numerator. So now let's incorporate the x squared. So if I want to incorporate the x squared, let me just bring it over here. So it's starting at 1. X to the 2n plus 1, 2n plus 1 factorial. And then I'm going to multiply. I'm going to have the x squared in the denominator, right? So it's taking this into account. So now let's join the x's together, because for my next part here, I want to take the integral, right? So I want to make sure I have all the x's together. So the 2n plus 1 factorial in the denominator. So combining these, so x to the 2n plus 1 minus 2 gives me an x to the 2n minus 1. So this I'm going to have inside my integral. And remember, when you're integrating, you're just going to be increasing the power of the x by 1. dx. Okay, so this carries along as a constant. This carries along as a constant. And I'm adding 1 to this exponent, so I get x to the 2n over 2n. And then make sure that you identify that it starts at 1. Okay, so I made up a new one here. So you don't always have to have division. You could have multiplication. So this says use the Maclaurin series, and really you can't do this integral. It can't be done. So that's why we like the Maclaurin series. So let's start off with just cosine of x squared. Because I know cosine of x is this new angle of x squared to the 2n over 2n factorial, and this is starting at 0. So that we want to always do the subtraction first. So let's look at our first term. So when I plug in n equals 0, I get a positive, this gives me an x to the 4n, putting in n equals 0, that gives me a 1 minus, and then maybe let me fix this so you can see. So this is x to the 4n over 2n factorial. Okay, so now when I plug in n equal 1 into here, I'd get a negative x to the 4 over 2, and then plus an x to the, and plugging in n equal 2, x to the 8 over 8 factorial. This is 2 factorial, or 2, right? Okay, so now I can see if I'm going to do cosine of x squared minus 1, the only thing I'm going to do for this sum is I'm going to take away the first term. So cosine of x squared minus 1, taking away the first term, means starting the sum at 1. So if I start the sum at 1, I've got the numerator. Now, or sorry, I've got the cosine of x squared minus 1. Now I want to incorporate the x cubed. So x cubed, I think I can do this all at the same time, right? Let's put it all in the integral. So the integral of x to the 4n times x cubed 2n factorial dx. Okay, so in order to integrate, you have to combine those two terms, right? So, and oh, I should keep my 1 to infinity, 1 to infinity. So I have negative 1 to the n, x to the 4n plus 3, 2n factorial dx. Okay, so now to take the antiderivative, I add 1 to this exponent only. So I get x to the 4n plus 4 over the 4n plus 4, and also with this 2n factorial, n equal 1 to infinity.